proper autonomy level of the robot, which levels of shared autonomy. Does the robot need to predict the human motions during teleoperations? Can we provide a balance between robot dexterity, maneuverability, stability while it's following the human commands? Then question about the mapping and reality gap, especially if we are having space exploration scenario. I really like the system for, even Enrico, where is Enrico? The system for removing the weight to the NASA robot. And then questions about intuitive interfaces. And for complex environment, also if we have to include the information about the environment where we teleoperate, because like in the example of Enrico, he had the wall, so the robot was using the wall to do the task. But like, do we have to give this information to the operator if we are in a realistic scenario, like a teleoperation scenario? I mean, which kind of interface we do that? And there are more questions, but I mean, we can also pull some of Joshua's questions. Who wants to start? Are there questions also from the public?
I will just start.
Yeah,
I would like to ask you a question. So about the prediction of the human motions, for example, in a telemanipulation scenario, maybe we want to use the prediction of the human motions to overcome the delay of the communication. But on the other side, for effective telemanipulation, maybe we need active feedback. And then again, there is the delay of the communication in that side. So what do you suggest how we can overcome this problem? If I was clear.
Well, I'll take a stab at answering that first. I think when I think of tasks over time delay and the idea of predicting human motion, I think I tend to frame it in the sense of predicting task performance more than specific human motion, because I do think that if you're directly teleoperating a robot via manual telepresence, and you have a lot of visual servoing going on yourself as the human operator in terms of modifying the way you move the robot in response to how it's moving in the environment, and you lose that when you don't have that direct connection over a time delay. And so I would say it's more about predicting the task that you're asking the robot to do, more so than it is predicting the specific trajectory of a joint or an arm or something like that. So I think that's a good way to think about it.
More predicting. So in that case,
But if we face the unexpected events, if we go to unexpected in an unstructured environment and you're far from the robot, so in that case maybe we cannot have the autonomous performance of the actions. So in that case, what you propose as a solution? So because most of, as I see, most of these solutions being provided today, maybe the user was doing it before a lot of times, we were simulating them before, but if we go to a case scenario that we should do some tasks, but we didn't foresee it before, what do you suggest in that case?
Maybe I just want to say, maybe I'm gonna, dodge your question, but I just want something that I want to point out is something that actually so a lot of the research that I do also look into biomechanics, and you would be surprised how slow machines people are. So if you, for example, take your touch feedback and then you do something about it, that takes something on the order of 120 milliseconds. And then if you do something based on vision, that goes to 250. So there's a lot that we do as people that relies on practicing emotion and then relying on your model and your feed forward on how we want to do it. I think that a lot of these machines that deal with, for example, my work, that deal with haptic feedback, they can work as a way for you to learn the dynamics and you learn how to do something. But effectively, when you're actually going to do in the real world, maybe you're going to rely you're just going to rely on your knowledge how to operate and feed for most of your tasks, right? So I think that is very inspiring on how we get around and control our own body, given that our neural system is so slow. And I think we can learn a lot for teleoperation as well.
If I could add to that, I'm not sure I could answer that rather than just throwing another monkey wrench into this. I've been working a bit on space, as you probably saw from my talk. So it's not just time delay, but the mixture of time delay. So just to give you a specific example, during our experiment, we have a voice loop, which is on one time delay, and then we have the video feed from in-cabin as another time delay, and then we have the robot commands, which is on a third time delay. So they all are feeding into my senses simultaneously, unsimultaneously, if you catch what I'm saying. And that, I have no way of dealing with that. So the way I dealt with it was I ended up just quit looking at a video feed because I couldn't take it anymore. And I have no answer to that. So rather than answering your questions, I'm just throwing another one at you. When you have different kinds of time delay, all feeding into the same system, at least when you have human in the loop, I'm not really sure how to deal with it and still taking in all of the feedback at the same time.
This kind of suggests that if, so to the operation for space or over large delays, at the end it's better not to be a human in the loop. So just a supervisor, or like providing very high level feedback, but not like joint feedback or task level.
Well, that's a bit of a move. Okay, so I don't think there's a one-line answer we can give. So working the robot at a task level certainly alleviate us of a lot of the workload, and also kind of helps us avoid some of the mistakes that we would end up injecting into the whole chain of operations, so to speak. But on the flip side, we still want telepresence. We spoke with geologists who, at least from my line of work, those are the real scientists in the space domain that we're trying to serve. We as roboticists are trying to provide a service, although sometimes, at least I forget that. And what they asked for is, he said, I want two things, or a couple of them explained to me, I want two things. I want to be able to see, so that's visual servoing. Okay, that's relatively speaking, in fact, kind of going with what you're saying, that's relatively easy. We're slow anyhow. The other is they want to be able to touch. So we can't run away from telepresence. But then we're talking about time delay now. So that, again, is a moving window. So when I started working in this area of teleoperation, I think the going rate was saying, to keep the controller stable, we're not talking about being comfortable as an operator. We're talking about maybe we can handle half a second delay before the controller goes unstable. And then, at least at DLR, then and also I've seen colleagues at ESA too, saying, okay, we can push it to 1 second. And some people say, okay, we can hit it to 1 second, but only load off, because again, it goes unstable. But then now we're pushing a bit farther out again. So then that's really a moving window that you're not gonna say, today you say I can hit 1 second time delay. Maybe tomorrow, in fact, I'm quite sure tomorrow would be a little longer. The human perception side of how you can handle it, that's something else. That's then another problem we're gonna have to deal with together as a community.
Your idea of if we need better
maybe I'll say something about it. So my way of thinking about this is sometimes a lot of work. I think there's a lot of great work out there, but I do think that sometimes when I see these interfaces, they look like they have a ton of overhead. So stuff that it's nice to have, and I would like to add and make stuff look pretty. But I think that my ideal interface would be something that is the minimum required thing that you can get away with that allows a person to actually control the robot. So maybe sometimes you cannot have the video resolution one, so drop that resolution to the minimum. The operator can still accomplish the task, but you get to the interface, you get to the speed that you want. Or maybe sometimes you cannot get enough. I cannot transfer all the degree of freedom, so condense that information as much as you can. But I think that the interface should focus on providing the minimum amount of information that you can still complete the task in a reasonable, time or efficiency, depending on what you're trying to measure.
So do you think about this? Because exactly, you have many different signals to get feedback from. Do you think it's possible to condensate the feedback status in the latent space?
Can you repeat that last part?
Imagine, because we have visual feedback, haptic feedback, for example, at verbally latent, I'm saying. Maybe we should find a way to condensate all this feedback information in a simple latent, sort of latent space, like compressed space that has no physical meaning. What else?
Yeah, so for example, if you look at whole body, so one way of thinking about feedback could be, I'm going to give you feedback for all the both four end effectors, 2 hands and 2 feet, and the central mass, or something like that. Or you can give just feedback that's the net effect of all these forces on the central mass, right? So you could think about what is the smallest amount of information I actually need to transmit that information, maybe not providing a full picture. So yeah, so I think for a whole body it could be something like that. For tactile, it's a little bit more tricky, especially because I don't know anything about tactile. But I'm also imagining that you can provide some force that, this is equivalent wrench on the end effector or something like that, and the point of contact, and trying to minimize as much as possible the information that you need to transfer. So maybe you can bump your bandwidth a whole bunch more if you can do that.
May I say something? Maybe if this works. Oh, thank you very much. So this is I'm sharing a personal experience. The only time that basically I broke the robot in the past was because I was not showing in the GUI the temperature of the motor, which is, let's say, I think it's one of the most important information, but no one showed today in the GUI. So, and sometimes we don't still show it, because if you have, for instance, in Centauro, you have 40 joints, then you have to show 40 temperatures, and you start to have a lot of numbers going around. And of course, it depends also on the task that you are performing. And so, I completely understand the point of showing condensate information, but the information should be also the one which is really useful for the operator to do something, because maybe you don't have at the robot side the autonomous behavior to prevent this, the dangerous behavior, okay? Maybe for many reasons. Now, of course, we can think to the super robot that can prevent anything and doing everything alone, but this is not the point. So so this is, I think, an information so together with all the rest, all the measurements and so on and so forth.
So yeah, I think what you're talking about is better user interface. We almost need the fighter pilot heads-up display for controlling a robot, and having those points of information be able to be clicked on, drilled down to give more information, and maybe have little warning things that are saying the temperature is going, and we haven't really looked at a lot of the interfaces, at least what I've seen. Now, I'm not a robotics expert by any means, but I think the interface and how we actually control or inhabit the avatar, the robot, and those are two different things. So it's really depending on, control can give you one set of interface clues, and inhabiting can give you another. So there's a lot of work to be done in that.
I like inhabiting word, study human life.
It's a continuum. You can just control or you can inhabit.
I'd like to ask another question. One of the common points in a lot of videos and scenarios we have seen today is the efficiency of the teleoperation of the robot, robot execution of tasks. And most of them, they are very slow. And in fact, most of them, they have like videos 4x, 2x, 3x in order to make it faster. What is the technology, do you think, in order to reach a point that the robots act in a close to the human level in terms of the timing and efficiency?
Well, there's a number of things. So as one person pointed out, during the DARPA Robotics Challenge, most of the time the robots weren't moving, and because the operator was doing something on the interface. So as you can add more autonomy or have more direct teleoperation so that there isn't those delays, then you get rid of that time. I think for us in the DRC, it was about 60% of our time was the robot was not moving at all. Then you just have the speed limits of the actuators themselves. So typically, robot actuators are less power dense than muscle. But you need the high torque in order to climb stairs, or so you usually scale back on the speed. A human joint can do about somewhere around 15 to 20 radians per second, and that's like way faster than just about any robot out there. There's some of them that you've seen today are probably getting maybe around 12, but most, a lot are as low as 4, so like 1/5 the speed of the actual joint speeds. So you have that. Sure. What are the other 20 things?
So I think that one of the things that will have to be improved in order to take the burden out of the operator is add robustness. Like one of the reasons why the operator is so slow is because the operator is fearing to break the robot. Like if I do a bad movement, the robot will hit the environment, and if the robot hits the environment, the robot falls. In the DARPA Robotics Challenge, all the robots were avoiding to touch the wall, for example. Or if you approach too much to the valve, and instead of just touching a little bit and stop, if you push even more, the robot will fall. So if you make a robust control, maybe compliance is involved in here, the operator does not need to take that long in order to plan, to say, okay, do this motion, do the other motion. And that can improve a lot the efficiency of the teleoperation system. That's my opinion.
There's also just the perception. So a lot of the sensors are still kind of slow, like a LiDAR to take a full scan of the room can take 10 seconds for some of the older ones. Those are getting faster and faster. Planning algorithms still can, some of them, depending on how you implement them, might take a few seconds to figure out the footsteps to take. There you can get away with starting to execute it before you have the full plan instead of waiting, but it's just, right now, it's just easier to wait till you get the full plan. Let's see here. There's the delay in the operator waiting to get confirmation that the last thing they're doing happened properly. So you might just, verify, oh yeah, it looks like that part's done, now I go to the next one, where if you're in real life, you wouldn't question whether or not I have the glass, now I have it. I wouldn't have to say, okay, yep, now I have the glass, now I can fill it. And some of those you might not be able to get around just because you're not there. Like imagine instead of trying to control a robot, you're talking to a friend across the world and you're trying to get them to do something. they're going to do it much slower than you would have had you there, because you need to get the feedback of what they actually did and what they learned and all that, and just so I don't think we're ever going to get to the point where we're as fast unless we can get just pure presence where you feel like you are the robot. So maybe a factor of 2 is what we should be shooting for, or 1.5 or something, but definitely better than 20. That all the videos that I showed were speed ups of 4 to 20.
So about the thing for feeding with the robot, do you know the phantom limb experiment or the sixth finger experiment? So I participated in one of the experiments with VR headset, and after some minutes, I was really like into the virtual reality. So I was really like feeling I have 6 fingers. Like at some point, it was also perturbating. So I don't know, but I mean, at some point, we have observed with students that sometimes when they put the VR set to teleoperate the robots, at the beginning they are very cautious because, I may break the robot if I do something. But after a while, they forget about this. And like, for example, I remember because this happened, one of my students was teleoperating for a while and was doing blah, blah, blah. And then at some point, the guy passed and he said, oh, yeah, come here. And then, no, because you're teleoperating, like, it's dangerous. And then, because he forgot somehow. So he didn't realize that he was operating.
But in that case, the robot has to do the same motion?
Yeah, the robot was,
No, the
yeah,
robot
so
was
we had a super
but
list.
okay, the robot was doing the same motion, and of course. But the point. Oh, thank you. But the point is, has the robot to do the same motion, or it has to understand that was not?
Yeah, I think in a good in a real situation, so in the optimal situation, you should have detected that it was an unintentional.
For me, I really would like to have the robot that if it falls and whatever happens, doesn't break. Because this is the point at the end.
Actually, I was impressed. Most of the new robots are very rigid. They are not soft.
In which sense?
The shells, everything is soft. Like, even like I was thinking when you climb the table, your body is a bit compliant. So I don't know if this that have better interaction. Like,
That depends for the purpose of the robot, I suppose.
yeah, but if you're sending the robot in a known environment, I don't know.
I mean, I see personally I see the teleoperated robot as a smart excavator. So I like the idea that I can a little bit be harsh with the robot because it doesn't break. The robot is super strong, can do the things that I could not do eventually. But I understand that it could be depend. I mean, I could imagine also a teleoperated robot which has any way to work with other human beings, like I don't know in space. I suppose no. That's so in that case maybe the robot has to be more gentle and then having a soft.
Soft in the sense of being gentle. Soft in the sense of being able to absorb shocks.
Yeah. Ah, okay. Resilient. Yeah.
I have another question. So, thinking about the point you said that maybe the user afraid that they break the robot or fail the mission.
Mhm.
I was thinking that should we teach the robot or have some let's say some indexes such that we provide this ability to robot that even if it fails for execution of some of the tasks, but it doesn't fail such that the whole mission fails. So if we want to take in this to account, what do you think how we can face this problem? For example, there is this work that they teach the robot how to fall such that they don't break the robot. What can we do for the more complex scenarios?
So, yeah, there are some researches about how to properly fall, for example, in order to reduce the impact on the robot. But several times the problem is that the robot falls because the system got into an unwanted error, for example. Like the first time that we fell in the DRC, which was at the point of opening the door. The thing is that we had a division by 0 in the control algorithm, so the not a number propagated to all the control loop. And that when you have this kind of situations, you cannot rely on a strategy to really cope with that.
Unit tests.
Yes. Yes. Yeah, well, that can be an option, right? But yeah, that can be done, or also I had in mind the idea that it would be possible to collaborate with people in material science, because they have some pretty amazing materials that can absorb the impacts, as you said. Like, but I am not sure how that could be used like to cover an entire robot, and if that can also have some disadvantages, like raising the temperature of the robot itself. But yeah, that mitigation of the impacts when the robot falls, that would be also a good idea to have.
And I have a very provocative question, because so I like humanoids, even so, especially with legs. But do you think, especially for the space guys, do you think they will ever send humanoids with legs on the moon or on Mars, or it will be like humanoid on wheels?
So again, the moving target seems to be the short answer of it, to me anyway. So one of the reasons we go with wheels is actually just because of energy consumption. Relatively speaking, legs are very energy intensive, but that's not something we cannot overcome if you go up with a power source like a nuclear power source. Then that ceases to be a problem. We've come up against environments that we want to explore where wheels would be limiting. So right now we use suspension that allows you to have a bit of undulation, and even then they're often passive. And so if you just get into tighter crevices or just tougher terrains, it's going to be a problem. So I don't have a definitive answer for it, but it does feel like something we will need if we want to be more be able to cover a wider range of terrain. And it's also, are you familiar with WEGs, wheel legs? So that's somewhere in between. That's gaining a bit of attention. So it's really just wheel leg slapped together as one word. And look those up. They build in a little bit of compliance into each of those legs of the wheel. And because it's a spinning thing, it behaves like a wheel, but it's able to then clamp onto or clench onto less regular terrain. So that's something to look into too.
I think it's a fair question, and I think it's not exclusive to the space environment. I think you could ask the same question about a number of Earth-based applications in terms of why would we ever do legs when wheels are so much easier. And I think it speaks to the specific task you're trying to accomplish. There are things that wheels just cannot do for you. And if you are in one of those situations, you are really going to hope that you have a robot that didn't have wheels. Can you achieve base level of success with a wheeled platform? Absolutely, if that's what you're trying to accomplish. But it, again, speaks to what it is that you eventually are going to ask this robot to do for you. And I think that's what you have to consider. I think we will send legged robots to places and to do things, both space and here on Earth, when the need calls for it and the application suits it. And as legged robots get better, the cost of entry, so to speak, on some of these tasks that could be done by either type of platform becomes a lot lower for legged robots also, and then you can take advantage of that versatility.
And just to add to that, so the paradox for the space community anyway, and actually, for example, on Earth, if you have hazard environments, which even if you have a known environment, it will become unknown. And the more unknown the environment, the more you're going to need an ability to traverse on a very unexpected terrain. So it's like what we were just saying earlier, it's a moving target. So once you get the power density of the power source up and you bring down the power consumption of the legged platform, then we can get there. And I think in at least in the space domain, we really could use some legs if it's workable. I mean, you've probably seen the either the documentary or the movie on Neil Armstrong first landing on the moon. They have to make an unexpected extra traverse, or actually flight, because the place they thought they were going to land on was too rocky. Legs would have been good.
Do we have questions from the public? So maybe to conclude, so just an exercise. Can you name, like, if you had to pick, like, the one technology that you think is most important to address your problems in teleoperation, what would that be? Like, if you had to choose one, just one, your favorite.
Whole body inverse dynamics.
All we need is funding. No, but I'd say muscle-like actuator, especially actuator that packages like muscle, so that you can have a large number of actuators in a small space.
I'll just reiterate, the interface, I think, needs to be flexible and robust and really match the what the robot needs to do.
Well, I don't know if I would overlap with anybody else, so I'm just going to name something that hasn't been said already. I would say that we need a robot that can respond effectively in the world without needing that real-time human in-the-loop presence at all times. So I would say something akin to affordance recognition, or the ability to walk into a room and understand how to interact with objects it hasn't seen before on a more human-like level.
And just to come around on the other end to come meet with you, I would very much like to see our time delay and the communication be shrunk down to the physical limit as much as possible.
Okay, maybe I will be a little bit repetitive. I will pick up the robust control.
Yeah, I think, well, I would agree with you if you want to solve robotics problem, but then I wouldn't have research anymore. So the thing I would like to have, so I can keep doing what I do, is actually to have, you know, as you said, communication get to the point that you don't need to worry about communication speed anymore. And I think the other thing is that we can probably get to, you can figure out, but communication is going to be the one thing that, you know, if you send robots to Mars, then now there's literally nothing you can do to reduce that communication problem, right? So I think if you could solve that one for us, I think it would be a great point.
So I don't know if about this problem of communication. I don't know if you are like fan of science fiction and books. Like have you read Asimov books or Asimov short novels? So there is one that maybe it's on this topic of communication with time delays. So there is a novel where they send a robot avatar on Mercury. And so there is the problem they want to control the teleoperate the robot from the Earth. And so time delay is too big. So they build like sort of gateways all around the solar system to shorten the delay. And then they have a system for teleoperating like with brain, with several interfaces. But then the robot on Mercury has like, it learns the dynamics of the new world, so it can interact on its own. That's the story. But so if you want a story for your children to explain this problem, it's very nice.
Just to add to that, unfortunately, right now the gateway. So okay, so we were talking about the TETRA satellites that communicates between the ISS and the ground, and those are gateways. And so we have 800 milliseconds time delay between ISS and ground through the TETRA satellites. The gateway is actually the reason we're slow. So, because the physical distance between ISS and ground is only 400 kilometers. It's not that far.
So gateway would be fast.
So the gateway is actually, every gateway you go through, you get a time delay. And that's actually when I was getting at wanting to shrink down that time delay down to a physical limit is essentially just trying to get rid of time delay out of the gateways.
At least you don't get hurricanes on the moon.
They do have earthquakes now.
On the moon?
Well, they also don't have air.
Okay, so I don't know if maybe we have to leave because we're around
Well, before we close, on behalf of all of these invited speakers up here, I'm sure we would all echo saying thank you to the organizers for putting on a wonderful, wonderful workshop.
Thank you.